Okay guys, let's move ahead in chemical thermodynamics. Now before getting into enthalpies of transformations, I just want to recap something about endo and exo. Now HR, HP is greater than HR, then del H is positive, and then we call it as endo. In case of endo, it takes heat from the system, so system cools, whereas in case of exo, heat is given out to the system. Why? Because HP is smaller than HR, so del H is negative, so heat is given out in case of exo, whereas in case of endo, heat is taken in. So whenever a system gives out heat while the process is on, we call it as exo, and whenever we have got to provide heat for the process to occur, it absorbs heat, so that is called as endo. Now let's check out some of the enthalpies of transformations. Now fusion, now best example for fusion is ice melting into water. Alright, so we require to provide heat, so it's an endothermic process. So del H is positive. Alright, H2 minus H1, so this is solid, liquid, ice, water, ice at 0 degree, water at 0 degree. This is enthalpy of reactant, this is enthalpy of product. Now H2 minus H1, water is at higher energy and ice is at lower energy, so HP minus HR is positive, so we have got to provide heat for that, so del H is positive over here, and this has to happen at constant pressure. Now when we talk about enthalpy of vaporization, best example is water to steam, 100 degree water at 100 degree steam at constant pressure. Here also we have got to provide heat. Alright, we know that it's latent heat of vaporization which we have got to provide. So since we have got to provide heat, the process requires heat, so del H is positive. Again, when we come to ionization, the enthalpy of ionization, example sodium gas and sodium ion gas. This also is gas actually. Sodium ion in gaseous state. So what happens is, here also electron, to strip electron we require energy to be provided, so del H is positive. And for this process, it is this which is given over here, the value. Atomization, that is enthalpy of atomization. Now chlorine Cl to diatomic, we want to convert it into atomic state. Again, we are breaking bond and making it into atom, converting the diatomic into monoatomic. So again we require energy, so that also del H is positive. And for this reaction, from molecular state we are bringing it to atomic state. The energy required for chlorine is 242 kilojoule per mole. Again, in case of electron gain enthalpy, it is negative, because if we try and understand chlorine, in case of chlorine, already chlorine has 7 electron in its valence shell. So in order to accommodate, so there is lots of intra-electronic repulsion. So in order to accommodate one more electron to get into chloride state, it has to shelve out some energy, and that is what is called as electron gain enthalpy. So electron gain enthalpy, now here in this case it is shelving out energy, it is shelving out this much energy, so that is what is negative. Del H is negative, and the value is for this Cl to Cl minus is minus 349 kilojoule per mole, so del H is negative. So that is all about enthalpies of transformation. It's all purely based on these profiles. Alright, so let's move into next step.